So first supervised algorithm or first classification algorithm that we are going to see is called as decision tree. Okay, it is one of the most fundamental technique in classification, and it's widely used and typically gives very good performance. Okay, and we are going to see how to build a machine learning model for decision trees. Okay, and then we'll also see how to use that model to make predictions, as well as how to build such a model in R and then evaluate it. Okay, so we'll go through this entire process of dividing the data set and then building the model, validating it, and everything in the context of a decision tree algorithm. Okay, we already saw what is learning, so we don't need to go into that. Okay, so let's take an example. Okay, so what is a classification problem? You have bunch of records, historical records, and then you have some answer associated with it, which is called as a class label. And then we need to build a model so that whenever a new record comes in, we need to be able to predict the answer, right? Predict the class label. Now let's be more concrete and let's take an example. Okay, so I want to decide whether I should play football or cricket or whatever it is, whether I should play the game tomorrow or not. Okay, that's the decision that I want to make, and the decision I'm going to make the decision based on the weather conditions that are projected tomorrow. Okay, so I look at the temperature, I will look at whether it's going to be clouded or not, or whether it's going to be rainy or not. Okay, so depending on these criteria, I'm going to decide whether, or I want to decide whether I have to play or not. Okay, and how would you do that? Essentially, the way machine learning happens in this particular scenario is that it takes historical data. Okay, did I play day before yesterday, and what was the temperature, what was the, whether it's raining, whether it's windy, and did I play 4 days back, what is the temperature, what is the rest of the weather conditions, along with the class label, which is playing or not playing. Okay, I have bunch of records like that, and then I build my machine learning model to predict for tomorrow. Okay, is that clear for everyone, the scenario and how machine learning is? Okay, great. Now I'll show you how a decision tree looks like. Okay, I mean, let's say we build the model on this historical data and we got the decision tree, and let's see how does it look like, and then we'll go back and see how to construct such a tree. Okay, and that when you look at the tree, it's absolutely intuitive and trivial to understand. So let's look at that. So this is how such a tree would look like. Okay, forget about this numbers for now. So what is this tree? It's essentially first asking, okay, what is the outlook for tomorrow, whether it's sunny, cloudy, or rainy. Is it sunny? If it is sunny, then I'll go and check the temperature. If it is less than 30, I will say play. If it is greater than 30, oh, it's too hot, and I'll say don't play. Okay, and similarly, if it is clouded, then I'll go ahead and say play. And if it is rainy, then I'll check the wind speed. If it is too windy, then I don't play. If it is less windy, I'll play. Okay, so this is an example of a decision tree, and you know exactly why it's called decision tree, because it looks like a tree and it is helping you to make decisions on playing or not playing. Okay, and these numbers are essentially the historical records that are distributed across across a tree. Okay, so in the historical data, I looked at last 2 weeks of data. So there are 14 values. That means 14 records, each with playing or not playing answer. Okay, and initially there were 9 play records and 5 don't play records. And then once I looked at the outlook, there were 5 sunny records, 4 cloudy records, and 5 rainy records out of all the 40. Okay, and then similarly, in that 5 of sunny records, there were like 2 for playing and 3 for don't play. And again, if you divide based on the temperature, there were 2 for playing when the temperature is less than 30, and there were 3 don't play records when the temperature is greater than 30. Okay, so these numbers are simply the training data, which is your historical data that is distributed across this decision tree. Okay, so this tree is very, very easy to interpret, right? So tomorrow, if I want to make prediction, I will ask you what are the independent variables, which are outlook, temperature, and windy. So you will say, okay, outlook is sunny, and temperature is 25 degrees centigrade, and windy is equal to false. Okay, this is the input record that you are going to give me for tomorrow. And then I will see, okay, I have to go through this tree to make the decision, right? So first I will say outlook. What did you say for outlook for tomorrow? It's sunny. So I go here. And then what is the temperature that you told me for tomorrow? It's 25 degrees centigrade. So it's less than 30. So come here. And then I'll decide I'm going to play. So I'll declare the answer to be playing. Okay. So that's the prediction that is made by the model. Is that clear to everyone? Is it clear what the decision tree is? We will now go into the details of how to constructing such a tree. Okay. Okay. Now, given this tree, there are a bunch of again more terminology. So there are a bunch of things. There's something called as a root node, which is the first attribute that is evaluated. And then there's a branching node, which are these intermediate nodes. Okay. And there are some leaf nodes. Okay. Leaf node is the place where you kind of made a decision, right? So as soon as we saw temperature is greater than 30, we'll say it's too hot and don't play, right? So that is the decision node in which you made the decision. So and it's at the last level in the tree, and therefore it's called leaf node. Okay. Now, obviously, in order to construct such a tree, what are the questions that comes to our mind? Okay. The first and foremost question is, so we have 3 attributes, right? Outlook, temperature, and windy or not. Now, out of these 3 attributes, what should I choose as the first attribute to split on, right? So here we are splitting our data set based on the outlook. But who tells me that outlook should be the first one? Why not temperature? Why not windy, right? So that's the first question. Given a list of attributes, how do I choose my splitting attribute? Okay, which one to choose? Piyush, cloudy will be again leaf node because it's not it's not branching out anymore. Because at this point itself we made the decision, and therefore it's the leaf node. Okay, so the first question is which variable to split on, whether in the root node as well as in the intermediate nodes. Okay, and the second question, so okay, you check the temperature, you check the outlook, you check the temperature, and then you need to decide, should I check the windy also, or am I happy to make a decision, right? So how long should I go down to make a decision, right? So that's again like a stopping criteria that we have seen in K-means, right? When do we start our process of building the tree? In k-means, it was like, when do we start the when do we stop the process of updating the clusters? And here the stopping criteria is when do we stop building the tree? Okay. And then the final question is that once I reach last level, okay, how do I make a decision here? So I told you that if it is less than 30, I'm going to play. If it is greater than 30, I'm not going to play. Okay, but how did I make the decision? Right? Why did I choose play here and don't play here? And why did I choose don't play here and then play here? Right? So that is a choice or the decision that you make in the leaf node. Okay? So those are the primary questions one needs to answer in order to build a decision tree.